Hello guys, welcome back to my YouTube channel. Today I am going to solve day 23 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 310, minimum height trees. So this question is asked in Google. Okay, so in this problem we have given a tree, and this tree is an undirected graph in which any two vertices are connected by exactly one path. In other words, any connected graph without simple cycle is a tree. Okay, so we have given a tree of n nodes labeled from 0 to n minus 1 and an array of n minus 1 edges. Okay, so n is equal to 4 simply means the number of nodes. So number of nodes are 4 here from 0 to 3, right? 0 to n minus 1. Okay, total number of nodes are 4 and numbering 0 to n minus 1. Okay, and how many edges are there? And edges are n minus 1. So 4 minus 1 is 3. So 3 edges. From 1 to 0 there is 1 edge. From 1 to 2 there is 1 edge. And from 1 to 3 there is 1 edge. Okay, so I hope that this is clear. And where edges A to B indicates that there is an undirected edge between the two nodes A and B in the tree. You can choose any node of the tree as the root. Okay, so we can select any node of the tree as a root, and when you select a node X as the root, the result tree has a height H. Okay, among all the possible rooted trees, those with the minimum height are called minimum height trees. Okay, so this is what we need to return. Okay, so we have to return all those roots where we get the minimum tree height. Okay, so we have to just return a list of all minimum height trees root labels. You can return the answer in any order. Okay, so you guys should know that what is the height of tree, how to calculate the height of a tree. So the height of a rooted tree is the number of edges on the longest downward path between the root and a leaf. Okay, so understand this line carefully. Okay, so this is how we calculate the height of a tree. So the height of a rooted tree is the number of edges on the longest, okay, see this keyword, longest downward path between the root and a leaf. Okay, so now let's understand this with the first example one. Okay, so let me copy this example one. Okay, so this is our example one. Okay, so here n is equal to 4. Okay, simply means that there are 4 nodes and numbering of nodes are from 0 to n minus 1, 0 to 3, right? 0, 1, 2 and 3, and we have 3 edges. Okay, 3 edges. This is first edge, second edge and 3 edge. Okay, this is given in question. Okay, so here it is saying that 1 and 0 are connected, right? 1 and 2 are connected, right? And 1 and 3 are connected, right? So now this is clear, right? So I can say that my 1 is connected with 0, 1 is also connected with 2, so I can make a diagram like this, right? And 1 is also connected with 3. Okay, so sum but this. Okay, so let's consider 0 as our root first. Okay, if 0 is my root, so here I am considering 0 as my root. Okay, and here in this example I am considering 1 as my root. Here in this diagram I am considering 2 as my root, and here in this diagram I am considering 3 as my root. Okay, so if 0 is my root, okay, then what is the height of my tree? So height of my tree is 2, right? This is 1 and this is 2, so height of my tree is 2. Okay, and when my root is 2, then in this case what is the height of my tree? Height of my tree is 2 again. Okay, so in this case also my height is 2. And what is the height of my tree when my root is 3? So height of tree when my root is 3 is nothing but 2 as well. Okay, in this case. Okay, so the height of a rooted is the number of edges on the longest downward path. Okay, longest downward path, 1, 2. Okay, and in this case you see when my root is 1, then the height of tree is 1, right? Then the maximum height of tree is 1. When my root is 1, then the maximum height of my tree is 1. Okay, and this 1 is smaller than 2, this 2 and this 2, right? So we have to just return this root, okay, in form of list. So here I am returning 1, right? So I hope that you guys are clear. So as shown, the height of the tree is 1 when the root is the node with the label 1, which is the only MHT, right? Minimum height trees. Okay, so now let's understand this with example 2 here. Okay, so this is our example 2. Okay, so here number of nodes is 6, and we are labeling the nodes from 0 to 5, right? 0 to 5. Okay, so you can see the nodes number, right? And how many edges are there? So edges are n minus 1, that is 5. So 1 2 3 4 5. Okay, so what this problem is saying, that 3 is connected with 0, 3 is also connected with 1, 3 is also connected with 2, 3 is also connected with 4, and our 5 is connected with 4. Okay, so here if I consider 3 as my root, then in this case what is the height of my tree? Height of my tree is maximum height. Okay, if from 3 I go to this 4 using this edge, and from 4 I go to this 5 using this edge. Okay, so maximum height is 2. Okay, and what is the maximum height when my root is 2, when my root is 4? So maximum height is, if I consider this path 1 and then this 2, okay, any of these edge, so maximum height is 2. Okay, but if I consider my root as 0, okay, so let's say I am considering my root as 0. Okay, so this is my root 0, and 0 is connected with 3. Okay, and 3 is connected with 1, right? 3 is also connected with 2, and 3 is also connected with 4, right? And 4 is connected, 5 is connected with 4. Okay, so I can draw my tree like this if my root is 0. Okay, so if my root is 0, then in this case what is the height of my tree? Height of my tree is 3 in this case. Okay, so you can check the same way with 1 as root, with 2 as root. Okay, and with 5 as root, you will get the maximum height more than this 2. Okay, so if we only select these two roots 3 and 4, then in that case what I'm getting the height as 2. Okay, and this is the smallest height. Okay, this is the smallest height if I compare it with the other roots. Okay, so we have to return both 3 and 4 here. Okay, so here now let's understand the approach that I am going to use to solve this problem. So let's consider I have this tree. Okay, so I have a one tree, okay, in which this 0 is connected with 1, and 1 is connected with 2, and 2 is connected with 3, and 3 is connected with 4. Okay, now tell me if I consider this 0 as my root, and if I consider this 0 as my root, okay, this is my leaf, right? This is my leaf because this is only connected with one adjacent neighbor, right? Only this node is connected with just one neighbor, right? And this is also my leaf because this is only connected with just one neighbor, right? So I hope that this is clear. So both 0 and 4 are my leaves. Okay, both 0 and 4 are my leaves, right? So if I consider this 0 as my root, then in this case I will get the maximum height as 5. Okay, 0 is connected with 1, 1 is connected with 2, 2 is connected with 3, and 3 is connected with the 4. Okay, so if I consider 0, which is my leaf, if I consider my leaf as my root, then in this case what is the height that I am getting? I am getting the height as 4. If I consider this 4, which is my leaf, as my root, right? So in this case what is the maximum height that I am going to get? So I am going to get the max height, okay, in all these cases. 1 2 3 4, again 4. Okay, so whenever I am treating my leaf nodes as root, in that case definitely I am going to get the max height. I am always going to get the max height because these are the leaves, right? These are the two edges. Okay, if this is a straight line, if this is let's suppose if this is a straight line A to B, and the distance from between A to B is 20 kilometer, then if I am standing here at this position and I look at this B, then definitely this is a 20-kilometer distance. Okay, from A to B, if I look at this position. Okay, if I look at a map, so it is going to show me a 20-kilometer distance A to B. If I stand here and I look for the distance from B to A, definitely I am going to see 20 kilometer only. But what is the possible case that when I'm going to get the minimum distance? Okay, minimum distance, only the case if I'm standing in the middle. Okay, if I'm standing in the middle, okay, C is the midpoint, and from here if I look at A, then I am going to get just 10-kilometer distance. Okay, if I look for B point, okay, then again 10 kilometer only distance, right? So my best answer is always lies in the mid, right? My best answer is always going to lie in the mid, okay, because from the mid only I'm going to get the lowest minimum height, right? So if this is C, from C I'm looking for A and B, so definitely I'm going to get the minimum height now. But if I'm going looking from A to B, then definitely this is the longest path, right? From C I can directly go to A, from C I can directly go to B. So definitely my answer lies in here, okay? If I directly check my mid, from mid if I check the height, okay, so this is 2, okay, so I am just picking my mid value, okay, so 2, if I am picking this 2 as my root, so 2 is connected with 1 and 1 is connected with 0. 2 is also connected with 3 and 3 is also connected with 4, okay. So in this case, what is the maximum height that I am getting? Maximum height I am getting in this case is 2, right, which is minimum, okay. When I was checking from leaf, then I was getting the height as 4, okay. When I was checking from the leaf nodes as root, then in that case I'm getting the maximum height, okay. But now if I look from the mid, okay, if I look from the mid, then I am getting the just max height as 2, right? Now you guys are clear with the leaf, why we are not going to select our leaf nodes, okay, you are clear with this point. Because if I am going to check if I am going to take my leaf nodes as root, then in that case I'm not going to get the minimum height, okay. So now check for the other possibilities, okay. So other thing, one thing is clear that we are not going to check for leaf, and one more thing, second point which is clear that mid is always going to give me the best answer, okay. So now let's check for 1, if 1 is my root, okay. So if 1 is my root, then 1 is connected with 0, okay, and 1 is also connected with 2 3 4, okay. So 2 3 4, okay. So here in this case, what is the height? 1 2 3, okay. So I am getting the height as 3. So 3 is still good than if I am picking still good than these leaf nodes, okay. But this is not best is only this mid one 2, okay. Same case for 3, if I pick 3, then 3 is connected with 2 1 and 0, and 3 is also connected with 4, okay. So in this case again I'm going to get the max height as 3, okay. So my best answer is this 2, okay. From if I am picking this 2 as my root, then in that case I am getting the minimum height of 3, right? So the answer for this will be this 2, okay. 2 is the answer, okay. So this is one case, okay. So in this case how many edges nodes are there? 1 2 3 4 5, okay. When 5 nodes are there, then I am getting the answer this single node, okay, just this one, okay. So now let's so I hope that this is clear, okay. So now let's take one more example in which we have even number of nodes, okay, in which we have even number of nodes. So 0 is connected with 1, 1 is connected with 2, 2 is connected with 3, and 3 is connected with 4, and 4 is connected with 5, okay. So this is the case, okay. So we guys are clear that we are not going to check for the leaves, okay, because every time we are going to get the maximum height, okay. So now let's check for okay, let's check for 1 now, okay. If I take 1 as a root, then tell me what is the max height that I'm going to get. 1 is connected with 0, right, and 1 is also connected with 2 3 4 and 5. So what is the maximum height? 1 2 3 4. 4 is the max height, right? If I pick this 4, then what is the max height? So again I'm going to get the max height as 4 only, right? See, 4 is connected with 3 2 1 and 0, right? And here 5. So again I'm going to get the max height as 4, okay. So here I'm getting the max height as 4, here I am getting the max height as 4, okay. Now if I select this 2, then what is the max height? If I am selecting 2 as my root, okay. So now see carefully, 2 as my root, I am selecting 2 as my root. So if I has 2 is connected with 1, 1 is connected with 0, right, and 2 is also connected with 3, 3 is connected with 4, and 4 is connected with 5, okay. So I am getting the max height as 3 in this case, max height as 3, okay. Now if I treat this 3 as a root, so, okay, if I treat this 3 as root, then 3 is connected with 4, 4 is connected with 5, and 3 is connected with 2, 2 is connected with 1, and 1 is connected with 0. Okay, so in this case also I am getting the max height as 3, right? Max height as 3. Okay, so both 2 and 3 are going to be my answer, right? Both 2 and 3 are giving me answer as 3. Okay, 3 height. So 3 is also giving the 3 height. Okay, so for this specific problem I have to return two nodes, 2 and 3. Okay, I have to return two nodes, 2 and 3. Okay, so I hope that this is clear, because if I pick 2 as my root, then I am getting the max height as 3. If I pick 3 as my root, then I am getting my max height as 3, and this max height 3 is going to be my minimum height of tree. Okay, if I pick these two as my roots. Okay, and for 4 you are getting 4, for 1 you are getting 4 max height, for 5 you are getting 5, for 0 you are getting 5. Okay, so in this case we are going to get the two outputs. Okay, two values in the output, that is 2 and 3. Okay, so every time you can make your own examples right now and try this. Okay, so every time you are going to get a single output in the result, or at most two outputs. Okay, so this is the possibility. Okay, so here you can say that every time you will get at most two values in the output. Okay, so this is one point, this is the first point. Okay, and also you guys know about this. Okay, so let me make it second point, and you guys are aware of this. Our result will always be in mid. Okay, and this we are not going to check from leaf nodes. Okay, because the leaf nodes are going to give me the max output. Okay, so let's say if 2 is connected with 3. Okay, so in this case you have what is my output. Okay, so in this case you have to return 2 and 3 both, right? Because from both the points I am going to get the max height as 1, right? Max height as 1. If I treat my 2 as okay, if I treat 3 as my root, then again max height is 1. If I might treat 2 as my root, then again max height as 1. Okay, so we are not going to check from leaf nodes if my height is greater than 2. Okay, if my height is greater than 2, or if the number of nodes, okay, if my number of nodes are greater than 2. So if these are the nodes 2, 3, 1 and 0, then why I have to check from the leaf? Okay, definitely it is going to give the max output, then I have to start from the mid. Okay, so I hope that this is clear. Okay, so I hope that you guys are clear with this explanation. Okay, okay, now I have explained about this. Okay. Okay, so now let's do one thing. Let's understand the approach that I'm going to use to solve this problem. Okay, so here this is the basic thing that I have to explain this point, right? So our result will always be in mid, and we are not going to check from the root, because we are not going to check from the leaf nodes. Okay, because leaf nodes are always going to give the max result. Okay, and every time you get at most two values. Okay, it may be single value, it may be two values. Okay, so this is clear, right? So now, so what how I'm going to solve this problem? So first of all, let's suppose this is my tree. Okay, 0 is connected with 1, 1 is connected with 2, 2 is connected with 3, and 3 is connected with 4. Okay, so first of all I have to make one adjacency list. Okay, every time, like I have solved previous two questions. In both the previous two questions related to graphs only. Okay, yesterday and day before yesterday. So I have solved two questions in which I think I have solved this using this adjacency list only. Okay, so first of all here, so first of all I have to make one adjacency list, and in this I have to write the neighbors. Okay, so 0 is connected with 1, and 1 is also connected with the 0. 1 is connected with 0 and 2, right? And 2 is connected with 1 and 3, and 3 is connected with 2 and 4, and 4 is connected with 3. Okay, so this is my adjacency list, okay, that I'm going to make. Okay, 0 is connected with 1. So okay, so I have to make one adjacency list first. Okay, this first point, and after making this adjacency list I have to check for the nodes which has just only one neighbor. Okay, and if any nodes has just one neighbor, then definitely these are going to be my leaves. Okay, so 0 has one neighbor and 4 has just one neighbor, that is 3. 4 is connected with 3 only, and 0 is connected with 1 only, so these are going to be my leaves. Okay, these are going to be my leaves, right? So this is done. Now this is my outer level. Okay, this is my outer level. Okay, so I have to implement queue. Okay, I am going to implement BFS. Okay, so level by level we have to traverse. Okay, so this is my outer level. Okay, and this 0 and 4 are my leaves. Okay, so I have to first add, okay, these 0 and 4 in my queue, because these are my leaves. Okay, so I have found all the nodes in which I have just one neighbor. Okay, so I have to add both 0 and 4 in my queue. This is done, right? I have added 0 and 4 which are my leaves. Okay, after that I have to check, I have to iterate, okay, inside this. Okay, from 0 I can only move to this direction, right? Okay, from leaf, if I want to move, if I want to traverse, right, so I can only move in this direction, and from this position I can only traverse in this direction, because this is the only connected thing, right? This is one connection between 3 to 4, right? From 4 I can go to 3, and from 4 there is only one point now. From 4 only I can go to 3, from 0 only I can go to 1. Okay, so now from 0 I move to this one. Okay, so right now, okay, so right now here, what is, okay, tell me what is the value of n. Okay, so n value is nothing but 5, right? N value is 5, that is why I have nodes from 0 to 4, right? And how many edges are there? Edges are also n minus 1, so edges are also 4, right? 1 2 3 4. Okay, this is done. Now initially I have to check, I have to run one while loop. In while loop I have to check while my n is greater than 2. Okay, in the while loop I have to check for this condition, while my n is greater than 2. Okay, this is what I need to check in my while loop. Okay, so right now my n value is 5. Okay, so my 5 is greater than 2. Yes, if this is true, then after that I have to subtract the size, nothing but the size, q size. Okay, what is the q size right now? So n is equal to n minus size. I have to do this. So size of q, what is the size of q? Is 2, and n is 5, so 5 minus 2 is 3. Okay, so that simply means that I have removed my leaf nodes, so that is why I am doing this, right? N is equal to n minus size, I have removed my leaf nodes. Okay, while my n is greater than 2, yes, so my n is greater than 2, then I have removed my leaf nodes. Okay, just directly check from my mid values. Okay, so what I'm going to do, okay, so this thing is clear, I hope. I am checking while my n is greater than 2. If yes, then I am decrementing n. N is equal to n minus size. N size is nothing but the q size. Okay, in the q I have added my leaf nodes. Okay, so 0 and 4 I have added. So size is 2. 5 minus 2 is 3. Okay, then I have to check for the neighbors of my this first. Let's say I am at this position. So what is the neighbor of 0? So neighbor of 0 is 1, so I am adding this neighbor here, right? And I have removed this 0. Okay, now after that I am going to check what is the neighbor of this 4. So neighbor of this 4 is 3. Okay, so I have added this 3 here. Okay, one by one. So now, okay, I have added this 1 and 3, then after it I have to remove this connection. Okay, I have to remove this connection. Okay, so I have to remove this connection from 1 to 0 and from 3 to 4. Okay, I have got these values right, 1 and 4. 1 and 3. Now I have to remove this connection. Okay, so after removing this connection, this is the another cycle. Okay, so first I have checked at this outer level, then I reach inside this level. Okay, so I have removed this connection. Why I am removing this connection? Because now if after I remove this connection, then definitely my 1 is going to be my leaf node, right? Because I have removed this 0. Okay, I have removed this 0, right? 1 to 0 connection I have removed, and from 3 I have removed this connection. Okay, this is done. Okay, so I have removed this connection. So now there is only one neighbor for 1, and there is only one neighbor for 3, that is nothing but 2 for both of them, right? So definitely 1 and 3 are going to be my new leaves. Okay, definitely 1 and 3 again going to be my new leaves. Okay, that is why I have ended the connection. Okay, so this is done. Okay, and I am okay. After ending the connection, now see 1 is only connected with one node, right? 2, so I have added it in queue because this will become my leaf, and 3 is also connected with just one node, so 3 become my leaf, so I have added it in the queue. Okay, this is done. Now after that, again I have to run again this loop. Okay, so now last time my n was 3. Again I am going to check if 3 is greater than 2. Yes, 3 is greater than 2. Then my sign, and now my n, after that my n will become n minus size. So again size of q is 2, so now my n will become 1. Okay, n will become 1, right? N minus size, so n is 3, size is 2, and n minus size n is 3, 3 minus 2 is 1. Okay, so my n will become 1. Now inside this, again I have to check what is the neighbor of 1. Okay, 1 is just connected with 2, right? 1 is just connected with 2, so 1 is just connected with 2. Okay, so I reach at this position. Okay, now once this is done, then after that I have to remove the connection of 2 and 1. Okay, so I have removed the connection of 2 and 1. Okay, so now after removing the connection, I am going to add this 2 here. Okay, I added 2 here. Then I have to check for the neighbor of 3. Okay, I have removed this one as well. So neighbor of 3 is 2. Okay, neighbor of this 3 is 2. Okay, now I have removed the connection between 2 and 3. Okay, now 2 is not connected with anything. 2 is not connected with anything, right? 2, I have removed this connection, and this connection I have removed last time, so 2 is not connected with anything. Okay, so I have just removed it, I didn't add anything here, so only thing left is 2. Okay, so uh, in the end, okay, this is the only thing that is available in my queue, right? So in the end I have to just return this 2. Okay, so I hope that you guys are clear, right? So this is very simple, right? So now let's understand this with an example where my n is 6. Okay, so I hope that you guys are already aware, right? Now you guys are very much confident in this. So my n is equal to 6 in this case. Okay, so 0, this is 0, 0 is connected with 1, 1 is connected with 2, 2 is connected with 3, 3 is connected with 4, 4 is connected with 5. Okay, n is 6, so that is why we have nodes values from 0 to n minus 1. Okay, and edges are 5. Okay, so first of all we are going to check for the outer level, right? This is my outer level, and yeah, first we are going to create one adjacency list. So 0 is only connected with 1, 1 is connected with both 0 and 2, and 2 is connected with both 1 and 3, and 3 is connected with both 2 and 4, and 4 is connected with both 3 and 5, and 5 is connected with just 4. Okay, so first both 0 and 5, both these nodes have just one neighboring node, right? So that is why both 0 and 5 are my neighbor, or are my leaves. Okay, so I have to add both 0 and 5 here in the queue. Okay, so initially my size is 6, so 6 minus 2 is 4 and becomes 4. Okay, then after that I reach here at this 1. Okay, I reach at this 1, and I have to remove this connection. Okay, and then I have to add 1 here. Okay, remove this 0. Then for 5 I reach at this 4. Okay, I reach at this 4, and I have to end this connection, and I have to add 4 here. then my n will become n will become 2, right? So now my n will become 2, and after that I reach at this position 2. Okay, I have to end this connection. I have removed this, so this will be, I have added 2 here. Okay, from 4 I have added I have reached to this position. Okay, so I have to end this connection and add 3 here and remove this. Okay, so now my n is not greater than 2. Okay, so I have to add both 2 and 3 here. So these both 2 and 3 are there in my queue. Okay, since my n is greater, I need n greater than 2, right? And see here, n greater than 2. Okay, but my n is 2 only, so I don't need to execute further. So both 2 and 3 are there in my leaves queue. Okay, so I have to return both. Okay, so I hope that you guys are clear. So in 30 minutes I have completed the complete explanation, right? So I hope that you guys are able to understand this approach. Okay, so now I'm going to write the same code. Okay, so first of all, let's say if n is equal to 1. Okay, in this case we have to just return collection dot singleton list 0. Okay, we have to just return this if the value of n is equal to 5. Okay, if my number of nodes is just 1. Okay, so in that case I have to just return 0. Okay, now after that let's create one list. Okay, so in this list I have to just return my answer, right? Result is of integer type. Result is equal to new array list. This is done, right? Then after that let's create one map. In map we are passing one integer, and then after that we are passing a list of integers. Okay, in the adjacent matrix. Okay, adjacent matrix that we are creating, right? So here you see list of integers, and this is just a single integer. So list and list of integer, and I am going to name it as map new hash map. Okay, this is done. Now we have to build the adjacency list. Okay, so I am going to iterate over each edge one by one. So for that I am going to write for each loop. Okay, so how we are going to write for each loop? For int edges. Okay, so then int u is equal to first value. Okay, first value, this is the first value, and then we have to pick the second value. Okay, edge 0, and int v is equal to edge of 1. This is done. Then same way map dot compute if absent. Okay, if this u is absent in our map, okay, if this key is absent in our map, then in that case just create a new array list. And if this key is already there, okay, if this key is already there, or if it's now, after that we have to just add our value. Okay, so what's happening here, I am checking if u is absent, then I'm creating one array list, empty array list, and then I'm adding v. And if my u is already there, then I don't need to execute this step, then I'm directly adding v. Okay, so this is the meaning of this compute if absent. If it is absent, then create new array list, then add. If it is present, then there is no need to create array list, just add. Okay, so I hope that this is clear. Now same way, this is if my u is the key. Okay, and same way if v, okay, it is an unrestricted graph, right? So if I'm 0 is connected with 1, that also means that 1 is also connected with 0. Okay, so that is why I'm going to write it like this. Okay, so I hope that this is clear. Then after that create one queue. integer leaves, okay, new linked list. Okay, this is done. Then after that we have to add initial leaf nodes to the queue. Okay, so every time I was adding leaf nodes in the starting, right? So I am going to write the code for that now. So for that, for int 1 by 1, okay, 1 by 1 I'm going to iterate over the nodes. Okay, int node in this map dot key set. Okay, so key set is the function, okay, here. And then if map dot get node, okay, I am getting one particular node, and if that node particular size, if the size of that particular node is equal to 1, then in that case we have to just simply add that into our queue. Okay, so we can use add or we can use offer. Okay, it's your choice. So I am going to use leaves.offer. Offer is much advanced than add. Okay, you can search on Google why it is more advanced than add. Okay, so you will find about exceptions. It is not going to give any exception or pointer. Okay, something like that. So this is done. And after that, now I have to make sure. Okay, one thing that that's for sure, that I know that my answer has, maybe it consists of just one output, or it may consist of two outputs. Okay, just like this. Okay, so at most two values. Okay, at most two values. So here I am just writing while my n is greater than 2. Okay, while my n is greater than 2, and inside this let's calculate the size of my leaves. Okay, so I have added all the leaves. Okay, so I have to take the size, leaves dot size. I took the size. Then every time I was doing this, n is equal to n minus size. So here I am writing it like this: n minus is equal to size. Okay, this is done. Okay, this I have already explained here, right? N is equal to then n minus size. That's what I'm writing here. Okay, this is done. Then after that, I have to iterate for int I is equal to 0, I is less than size. Okay, so I have to level by level I am traversing, right? So first this is my outer level, then for this outer level these are the 4 nodes. Okay, these are the 2 nodes 0 and 4, and then I have to compute for both. Okay, I have to check for both 0 and 4 neighbors. Okay, so that is why for int I is equal to 0, I less than size, and I plus plus. Okay, this is done. Then after that, what is my leaf? Okay, so I am selecting my leaf, so this is my first leaf. Okay, so int leaf is equal to q. What is the name of my queue? Leaves dot poll. Okay, so I am removing this element. And then what is my neighbor? So I am going to get the neighbor, int neighbor. So neighbor, how I am going to get? So map dot get which node? Leaf node. Get this leaf node, and then iterate over this leaf node. So I am going to use this iterator. Okay, iterate over this row. So my iterator is right now present at leaf. So now after taking this iterator, I am just selecting the next. So it is going to select the next value. Okay, so 0. Okay, from 0, what is the value available? 1. So I am taking this 1. Okay, so this is what I am calculating the neighbor. Okay, then after that, if I calculate this neighbor, I have to remove the connection between them, right? So from 1 to from this neighbor I can just remove the connection. Okay, so from the neighbor only I need to actually delete the connection. So I am going to write it like this: map dot get neighbor dot remove. Okay, and here we are removing, so we are removing one integer, which is a value of integer dot value of leaf. Okay, okay, this is done. So here we are removing the leaf from the neighbors adjacency list. Okay, and if you want to maintain your adjacency list as well, then you can also remove the leaf. Okay, for that particular leaf you can remove the neighbor. Okay, so for that particular leaf you can also remove the neighbor. Okay, but it's not required. Actually we just need to return the minimum height tree, so that is why I'm just writing this only. Okay, so this is done. Now after that I am checking if my map.get neighbor, if map.get neighbor, okay, for that particular neighbor, if the size is 1, okay, so that's I have already explained. If my size is equal to 1, then that means that it's my leaf. Okay, then in that case only I am adding that into my queue. Okay, leaves dot offer and neighbor. Okay, this is done. Okay, this is done. Now okay, here this is completed, this is completed here, and this is where our this is completed. Okay, then after that we have to just this is my result. Okay, dot add all. Okay, it is going to add all the queue elements in my result list. Okay, and then in the end we have to just return result. Okay, okay, so let me check if everything's correct here. Okay, this is done, this is done, this is done. Okay, let me format the code. So now let's run the code and see if there are any issues. So all the test cases has been accepted. Okay, so here one thing, so here let me create one test case. Here I am just passing this one. Okay, just passing this one. Okay, see if my n is equal to 1, and then see the output is like this. Okay, so I hope that you guys are clear at this point as well. Okay, so for graphs you already know what is going to be time complex, what is going to be my time complexity, right? It is going to be 0 of v plus e. V is nothing but vertices, and plus e means edges. Okay, so how many vertex or nodes are there? So 4, and what are the number of edges? Okay, so this is worst case time complexity. Okay, and same way space complexity is also going to be same. We are also using queue, right? So let me submit it. Okay, we haven't submitted it yet, right? So let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. So just 35 lines of code, right? And this question is asked in Google, right? So just revise it, revise this question back after 2 to 3 days. Okay, otherwise you guys will forget. Okay, so if you guys have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video, and don't forget to like, share and subscribe my YouTube channel. Thank you. Bye bye.